guys, today we're going to go over 1.3, which is pretty much describing quantitative data with numbers. We're going to go over mean, median. I'm going to mention mode even though it's not in the book. We're going to go over what a resistant statistic is, and also we're going to end the video with how to calculate standard deviation by hand. It's actually quite simple, so don't freak out. First, let's begin with the mean, represented like this. That's called X bar, mean, average. So a whole bunch of ways to call this. All you have to do is add the number of measurements, or add the measurements and then divide by the number of measurements. That's how you get the average. So for example, 1 plus 2 plus 3, I add these 3, I end up with 6. There are 3 measurements, so you divide by 3, 2. The mean of these measurements is 2. We've been over that multiple times. I just wanted to review it. Now, the median pretty much wants to find the value that has half the measurements above it and half the measurements below it. So let's say, for example, 1, 3, 4, 5, 6, 6, 8. The median would be 5. There are 3 values below it and 3 values above it. Now note, sometimes the values aren't given in ascending order. So please don't just count and then select the middle one. Make sure you order them first properly. 1, 2, 3. And also, many students cross out the numbers that they are putting. I would not recommend crossing them out, because if you do a mistake and you have to go back, it's going to be rather difficult. If you want, you can just put a dot on top. 1, 2, 3, 6, 7, 8, 8. That way, if you have to go back, you can clearly see the numbers. Now, in this case, 1, 2, 3, 4, 5, 6, 7. There are 7 measurements. When it's an odd number, you can easily just pick the middle value, 3 above, 3 below. But when you have an even number of measurements, 1, 2, 4, 8, when you have an even number of measurements, there are 2 numbers in the middle. Which one do you use? Both. You actually take them and average those 2 out. And that would be the median, even though that value does not exist within my measurements. So whenever you have an odd number of measurements, the number in the middle is the median. When you have an even number of measurements, you add the 2 middle measurements, and that value would be the median, even if it is not represented along the measurements. Now, the book talks about resistance before talking about the median. And I think this will help you visualize more or less how resistance work. Now, the definition given in the book, it says that a statistical measure is resistant if it isn't sensitive to extreme values. So let's go over 2 examples. Let's say, for example, I have 10, 50, and, or let's say 10, 40, and 50. I have those 3 values. If I were to average them out, this would be 100 divided by 3. It would be more or less 33. Pretty simple. And also, in these exact measurements, if I were to take the median, it would be 40. So that's pretty much expected. So I have a median of 40 and an average of 33. Note that the more extreme the values are, the more the mean might change, but not necessarily the median. Let's go over what would happen now. Let's change this 50 for 1,000. That's an extreme value. Let's change that 50 for 1,000. Now, when I add this, I would have 1,050, and the average, this divided by 3, will be 333, 350 or so, more or less, give or take. That's actually exactly how much, I think, 350. So note how one extreme value pulled the mean from a 33 to a 350. But what is the median of this measure, or this population of measurements? Still 40. So that 40 did not really change to the addition of an extreme value. So the medians are resistance statistics, the means are not. The means are pulled one way or the other by extreme values. The medians don't really care. Okay, again, another example. 1, 2, 3, 4, 5. The median is 3. The average would be 3 as well. I change this 5 to a 200 or a 300. The median stays the same. The mean would then be pulled to a higher, so it would be pulled to the right. So median resistant, mean not resistant. I hope that clears it up a little bit. Now we're gonna go over standard deviation. You know, I really love standard deviation. We use it a lot in medicine to actually understand how normal or not normal a measurement is compared to the population as a whole. I think standard deviation, understanding that concept will just help you really be able to understand normality, abnormality, extreme abnormality. It's actually quite interesting. Now, the way standard deviation works is there are a couple of steps, and I'm gonna go, okay, let's go over standard deviation, but I forgot to talk about the range. We've seen this in 7th grade. The range is just the maximum value minus the minimum value. These measurements, maximum value minus the minimum value, the range would be 5. So again, kind of forgot it, but it's too simple. So range, the difference between the maximum and the minimum value. Now let's go over standard deviation. The definition the book gives you says standard deviation measures the typical distance of values in a distribution from the mean. How far away am I from the mean? Now, the way to actually calculate it by hand, let's go over the measurements the book gives us. The book gives us let's just go over the measurements. 2, 2, 2, 3, 3, 3, 3, 3, 3, 3, 3, 4, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a 6. Those are the measurements that are given by the book. Now, the first thing you always do when you have all your measurements is you take the average of that population. In this case, when I add everything and I divide by 11, the mean of the population is 3. Now the next step is you take each and every value and you subtract the mean from that value. So how far away is this number from the mean? How far away is this number from the mean? How far away is this number from the mean? And you continue doing this for all values. This would be -2, this would be -1, this would be -1, this would be -1, this would be 0, this would be 0, this would be 0, this would be 0, this would be 1, this would be 1, and this would be 2. So I found the difference between the values and the mean. Now remember, again, it's your values minus the mean. Now when you visualize all these differences, I'm going to write them up here just so we continue discussing a very important part. -2, -1, -1, -1. I'm not really going to put the zeros because I don't have to. Then I have 1, 1, and 2. Let me confirm. Yeah, 1, 1, and 2. Let me just confirm. I'm the math teacher. 6 minus 3 is 2. Yeah, makes sense. Galaxy brain. 6 minus 3 is 3. Please do not lose confidence in me. I will pull through. So now let's change this value for 3. Now note, this is also known when you go over physics. I can't remember the actual term, but it's like the standard error, if I'm not mistaken. And if you say, for example, 10 different people measure something and they came up with these errors. If I were to add these errors straight up, I would end up with 0. oh my God, there was no mistake and there's no error. It all balanced out. The thing is that there were errors. These were under what's expected and these were above. So that is why when you look at the actions, you square the values and then at the end, take the square root to go back to more or less the original values. So we square the values, so we end up with a positive difference, and then you do the square root, so you have an idea of how variable the measurement was without canceling out the values. So again, if I were to just add this, I would end up with 0 as a total error. That makes no sense because there were errors all along the way. So this squared would be 4, this would be 1, 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 this would be 9. Those are the values squared. Now, after you square your values, you're going to do the following. You're going to add all the values, 4, 5, 6, 7, 8, 9, 18, and then you will divide either, if you're using the population, you will divide by the number of measurements. If you're using a sample, it's the number of measurements minus 1. So as you can see in the exercise, 11, which is a sample, of course, of high school students. So we're going to be using n minus 1. Now, since there were 11 measurements, you divide by 10. You add all the errors, including the zeros, for which there were 4. 1, 2, 3, 4. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 measurements in our sample. I'm going to divide by n minus 1. And pretty much what you end up with after you divide this is 1.8. Now, the final step of this process is just to get the square root of that number. And you end up with 1.34. Now, again, I know the average and now I know the standard deviation. And the same thing applies for last year. So this will be 4.34. And then you subtract, and that's how you manually calculate standard deviation. So again, to review all the steps in a more clear fashion, step 1, we find the mean. Step 2, we take our values minus the mean and square them. Step 3, we add all these values, including the zeros, and we take an average of those values. However, remember, if you're using a sample, it would be the number of measurements minus 1. If you're using the entire population, it would be all those numbers. After that, you do a square root, and that is the standard deviation. 4 easy steps. We will be going over those in class. So again, that's it for today. Have a great day.